With that, I'm going to turn it over to Dr. MB.
Great. Thank you so much, Vinny, and really lovely and an honor to be with you all and have an opportunity to present what we've been working on here. Shall I go ahead and present from my screen? That's the
Yes.
best.
Yeah.
Sure.
Okay.
Yeah.
Will do. Okay, wait a moment here. There we go. And all right, can you all see that full screen?
Yes.
Good, excellent, thank you. Great, so again, a real privilege to be able to present to you all what we're doing, and I'm very pleased to be joined by my MPIs here, Drs. Colin Walsh, Lori Novak, and Megan Solway, and they'll cover portions of the presentation. We've got quite a bit to walk through and want to leave plenty of time for discussion, so I'm just gonna breeze right through and get started. The medical condition of interest that is the focus of our work is related to preventing hospital-acquired venous thromboembolism. And we could say a lot about that, but I'll just keep it brief to say that 50% of all blood clots are healthcare associated. And this is a major health issue that, as you'll see, we felt like we were in a good position to be able to address and simultaneously learn a lot about how we could apply AI in pragmatic ways and advance this important research with that as our central focus. So that was our central focus. This is an overview of what we will go into a bit more detail about in terms of our progress update here today from our proposal, which articulates and sort of demonstrates the relationships between the three major aims of our proposal. So as is the case with our colleagues in the other programs, of course, we have as the core element of this a pragmatic clinical trial related to an AI decision support intervention. And in this case, it's related to the hospital-acquired VTE models, which we'll talk more about. Our second aim then is about developing, deploying, and evaluating what we call VAMOS, which is an algorithmovigilance monitoring system, the Vanderbilt Algorithmovigilance Monitoring and Operations System. And then our third aim, which we will not pay quite as much attention to today because of time and kind of where we are in the progress of this, but is important to the overall project, of course, is the development of a proactive risk assessment toolkit to inform future implementation of AI-driven solutions that integrate into clinical workflows. Our team, very briefly, I won't read all the names, but it includes a range of individuals. So, of course, we've got our major MPIs who have been doing most of the heavy lifting here, but we've got a significantly extended team as well that is contributing in various ways in terms of expertise around decision support, around privacy and security, AI monitoring and responsiveness, clinical expertise and biostatistical and data science expertise, as well as human-centered design. In terms of context setting, for our first aim, a couple of the distinguishing characteristics of this project are that we are involved, as you'll hear more about, in evaluating the effectiveness of AI-CDS approaches to prevent, as I've mentioned, hospital-acquired venous thromboembolism. And importantly, we are deliberately doing this across urban and rural settings. So we have our central campus medical center at Vanderbilt University Medical Center, and then as part of our larger network, we have hospital systems, hospital entities based in rural counties. So the one depicted here is our other main rural hospital, which is in a designated rural county of Coffee County in Tennessee, the Vanderbilt Tullahoma Heart Hospital. I'm going to turn it over to my colleague Colin Walsh to take it from here for a significant amount of aim one, and then we'll turn it to my colleagues Lori and Megan for the remainder of that discussion, and then I'll pick it back up with aim two. Colin?
Great. Thank you, Peter. So the mature algorithms we're going to be deploying here, on the adult side is called VTE AI, and that was developed and worked prior to our grant. That really is a prognosticating algorithm looking at risk of hospital-acquired venous thromboembolism. That's the needle we're trying to move with this particular trial. By combining insights from an algorithm like VTE AI via human-centered design and putting CDS into the clinical workflow, we're hoping we can reduce the incidence of HA-VTE across both urban and rural sites, as Peter spoke to. Critically, though, the clotting is just one side of the coin. On the flip side, prophylaxis can lead to increased bleeding events, and patients in general, the severity of illness that patients have can affect things like their length of stay, readmissions, and others. So those are secondary outcomes we'll be tracking over the course of this trial. Next slide, please. So over the last few months, we have been really engaged in invigorating work and actually standing up this trial, understanding current state even better than we did when we submitted our proposal. And really, there were three main work streams I want to highlight in terms of what we've been doing to approaching scalable CDS in this problem space. The first was really taking an inventory of the means with which we can integrate prognostic algorithms into clinical practice. It's easy for me to say that, but when you actually get into the weeds, there's a number of options at the table, and it was critical to us early on to figure out what those options were, looking at those pros and cons, and then making a selection. For example, we can build risk algorithms directly into Epic. Regression models, for example, are really well suited for that. Epic Nebula is a more recent development from Epic, which looks more like, for those of us who spend a lot of time in data science, your Jupyter Notebook environment within Epic. And that permits, again, different pros and cons. There are also our systems that live alongside Epic. So TIBCO is one example at Vanderbilt we've used in prior work, unrelated to this particular grant. And that's an enterprise service bus that's basically an active listener, watching for events to happen in EHRs, and then based on... Oh, heard a little background there. Please let me know if anybody has a question. That essentially allows us to do things like, in more real time, transactionally run a model at the point of care. And then finally, the modality we're going to be going with here is using a cloud infrastructure called Databricks, which stands up versions of our EHR data, including Epic Clarity. We're an Epic shop, like many of you are. And we're going to be using that to build the models, and also to give us better transparency in terms of how the algorithms are actually working, where they may be going wrong. And obviously that informs some of the other aims and the work you'll hear about from my colleagues. Now, in the middle, we had to actually really get into some deep analytics, not just standing up the risk model in production systems, which we've now done. You'll see a slide subsequently in terms of gaps between a research grade model that was published prior about this particular algorithm, and then what we see when we move over to production. We also needed to find prophylaxis. So what were the interventions that a system like this will guide? How do you find those at scale? How do you understand what the baseline prophylaxis rates are across services and locations? And then now that we're going to be introducing CDS, knowing those rates might change. And then finally, finding the outcome. So relying on the literature and pulling a scalable algorithm, finding HA-VTE in medical charts. This is not predictive, this is descriptive, but mission critical to getting this work done. And then finally, understanding the timing and availability requirements of systems like this. For example, one thing that we saw in standing up a clarity-based version of this model, which is a little bit different than the research version of the model that was originally validated, central line data are not available at the same moment in clinical production as they might be in a research repository. Again, somewhat obvious to say, but an easy detail to gloss over. And then as we get into the last mile work, as we've been, understanding how we bridge those gaps. And that's a good segue to the next slide, please. While we're standing up this work, we also need to understand that, there's versions of these studies that happen at the big academic medical centers, like our main campus sites, but we're part of a rich health system, like many of you are. And the way we've bridged to our regional health systems largely is through collaboration, leadership, and championship. So first, we've identified leaders. A lot of those were initially their clinicians that also have quality hats, and they've become leaders and champions for us putting this forward in the regionals. We had to understand the way they make decisions. What's their governance process? There's similarities, obviously, to what we do in Nashville, but there are differences too. Understanding and confirming IRB reliance. So if our IRB at the main campus, will that oversee the work that's happening at the regionals? And we were happy to confirm that we did confirm that that's true. The same analytics I just described in the last slide apply in the regionals as well. Understanding differences in the current state, as well as what we predict with the trial across both sites. And then finally, in the language that's going to be readily understandable at the regional level in terms of how they make decisions, preparing briefs for leadership to take to the table so that we can proceed. So all of this work was necessary to stand up this type of a trial approach in both sites. Next slide, please. And then finally, I've said some of this before, so I won't reiterate in the interest of time. Understanding and finding gaps as we move into implementation. So what I'm showing on the right, this is a decision curve. It may be familiar to some of you. I won't go into this in great detail, but the basic idea here is, before we implement a predictive model, with understanding of how that model might identify true positives, false positives, et cetera, at different risk thresholds, we can plot out the prospective benefit of implementing these models into practice. So just to orient you, the threshold for the risk model is shown on the bottom. The y-axis shows the net benefit, which is based on a couple of things: the true positives, the false positives, and the odds. And a higher curve is better. And the whole point of this this point is to say that our validated model from research on the same exact encounters has a higher net benefit than the initial cut of the model that we built into Clarity. So we need to look at this to understand same model, same specification, similar input data sources actually look different just going from research to production. So the more recent versions look a lot closer to the original setting, but I wanted just to take a point on this because this applies to a lot of predictive models that we want to translate across the last mile, moving from published research into production. So with that, I will pause and Peter, please move to the next slide.
Great, thank you. I think Lori's going to pick up from here.
Yep, thank you. Thank you. So we have on our human factors team, we have human factors engineer and 2 anthropologists. Joyce Harris, Megan Solway, and I have been doing interviews and observations.
I'm sorry, Lori. It looks like, I'm sorry to interrupt. I wonder if someone can mute. Jim St. Clair, if you're listening, I wonder if you could mute or if someone could mute him. Thank you.
Yeah, so we've been doing interviews and observations in both pediatric and adult settings, working with physicians, nurses, nurse practitioners, and clinical pharmacists, identifying ways that the clinical culture around VTE risk manifests in terms of both sort of cognitive patterns, perceptions, and also actions that people actually take. So looking at how do people think about this, and then what do they actually do? And we are finding that both of these things vary by the patient type that they're working with, by the clinical setting. There are definitely norms in different clinical settings. And then the expertise of the health professional. So a clinical pharmacist might be looking at different things than a nurse is looking at. And so for example, we're seeing in the ICUs and in the surgical units, they feel pretty much all their patients are high risk, whereas in the pediatric setting, there's a lot of resistance and concern about using blood thinners on babies. And so there's a lot of, taboo around that or concern around that. And so those are some variations we're seeing in terms of the culture. And then looking at the workflow, then how we would actually, accommodate that. We're examining the admission workflow, so bringing patients into the system, and then ongoing assessment. We're already seeing opportunities for decision support. One is the complexity of risk-benefit assessment, as Colin was just alluding to, thinking about the greater landscape of risk and benefit assessment and the risks of clotting versus bleeding, and how those things can even be, patients can be at high risk of both of those things at the same time. And also assistance in choosing medications. So those are some of the things that we're looking at. And then I think I'm passing off to Megan for the next slide.
Yeah, thanks, Lori. So as Colin and Lori both just described, we've been taking a lot of time and a lot of different angles and approaches to look at this problem and to really get a full picture of what are current clinical workflows, where are really the needs for this intervention, and how can we best do that. So we're still in the process of doing a lot of field work. But right now, what we expect our intervention to look like is some type of risk assessment on admission into the hospital, and then subsequent daily nudges if a patient's risk is to change throughout the stay. So you could imagine maybe a patient's low risk when they get admitted, our tool doesn't flag for them, but then a week later, their risk is suddenly really high. And so at that point, we would send a reminder that they might need to start VTE prophylaxis. And the idea is that these would be smart nudges. And so they'll be informed both by the patient's current prophylaxis status. So if they're flagged as high risk, but they're already on anticoagulants, we wouldn't send an alert. And as well as if there's any relevant contraindications that would indicate that they shouldn't be put on VTE prophylaxis. And we also expect, because of all these variations we're seeing between adults and peds and the main hospital and regionals, there'll probably have to be some element of tailoring and thinking about how do we fit this into the workflows for the different users in those different settings. So next slide, please. Yeah, so just overall next steps for AIM-1 and for the intervention study is to conclude our field work, which we anticipate finishing up in the next month or so, with still a big focus on trying to understand what's happening at the regionals. So we have a pretty good idea of the main campus, but how do workflows differ in those different locations, as well as between adult and pediatrics. We'll then finalize our intervention design and do some usability testing with end users, and then of course implement and evaluate. So the exciting part of this work to see, what impact does this tool have? So that's it. Back to you, Peter.
Thank you so much. So that concludes our overview of sort of the progress update of AIM-1, and I'm sure we'll have an opportunity to talk more about that. We're going to now pivot to just tell you a little bit about where we are with AIM-2. And for those who haven't been as involved in this, we just wanted to give you some orientation. So the concept of operationalizing an ongoing evaluation and monitoring capability be applied specifically to these algorithms, but more broadly, it really builds on this concept of algorithmovigilance, which I wrote about a few years ago, and we have been in the process of operationalizing here for our overall governance structure. And we're really using this project as a real key motivating use case to actually develop out the platform, and then importantly, be able to take lessons learned and continue that work. So in terms of the actual sort of overview of what it is we're building and deploying, we're referring to it as Vamos is a novel socio-technical system, which again enables organizational governance and oversight, capturing and reporting of adverse effects, team-based monitoring, and responding to issues, with the idea that, and we'll show you some mock-ups here in a moment in terms of our progress, but the idea that for each of our algorithms that's actually running in the organization, including the ones that are relevant to this project, we would set bounds around various metrics of consideration. Examples of those include accuracy and precision, drift, responsiveness to the actual decision support alert related to the AI-driven CDS, and measures of fairness and equity. And that what we really want is, as near real time as possible, to be able to capture and identify where it's going out of bounds according to those. We also are building in capability for feedback, recognizing that that's an important critical piece of what we need, both from the end users, but also to be able to provide feedback to relevant stakeholders. And then in terms of possible actions that could result from that, they range, including potentially investigating the cause, correcting and updating the model, notifying teams as relevant, and pausing the algorithm. We're really taking this learning health system approach that we've been also working on in parallel here for quite some time, and kind of applying it to this idea of AI CDS. This is a publication that some on our team published back in May, and as we've been continuing this project, it really informed this as well. So I wanted to share this as a point of reference, where we're really looking at this on a continuum basis in terms of a 360 approach, where there are stability-focused design elements for preventive capabilities to prevent the development of adverse effects and be able to anticipate those. The preemptive approaches of technical oversight include such things as recognizing, as we will in the case of these algorithms, to the extent that we know what systems are they reliant upon, what data feeds and interfaces are they reliant upon, and therefore, if there are any technical changes that happen, we can anticipate that there could be changes and have documentation of that. The core element is really around data-driven oversight. So recognizing that once we deploy these, we want to be monitoring process and outcome measures and various other metrics, and have visualization of that. And that's the responsive element. And then the reactive element relates to end user reporting, recognizing that we also want to have that capability to be able to respond if people bring up issues that we otherwise haven't caught. Some of the work that we've really been doing here to advance this effort relates to work that we've been doing with our industrial engineering colleagues and human factors experts around conducting a range of stakeholder workshops, and then developing our prototypes accordingly. So we've drawn stakeholders from across our medical center involved in various aspects of oversight, governance, implementation of health AI, sought additional perspectives from those in quality and safety across the urban and rural areas of our health system, and data scientists, as well as physicians and nurses. We sensitize the participants to some of the considerations that they might not have given quite as much thought to prior to coming in, around why we're concerned about this in the AI domain and potential risks, and then use scenarios to gain their input for the UI design and building the mock-ups and now the initial versions of our platform. Some of the things we've identified, so essentially some early results of that work that have really informed this, include a recognition that there's a range of users that need to be supported with such systems and approaches, that there are various use cases across the different algorithms and implementations, that metadata associated with the algorithms is really critical. For instance, organizational contacts and other kinds of people that would need to react if we saw issues. Support analytic functions, including performance metric monitoring and drift detection, has been a considerable aspect of this. Having flexibility to be able to actually, depending on the algorithm's purpose and intent and where it's deployed, be able to customize and even present temporal displays, as I'll show you in the mockup. Again, the feedback was confirmed in terms of the importance of receiving and displaying that. An ability to actually capture notes and log actions around what was identified and what responses were taken, and having the system support that. The ability to create reports that could go to multiple audiences about what it is we're seeing at different levels of the organization, and then generally communication about algorithmic management across the technical, operational, and clinical teams as relevant. So moving into just a little bit about how this is all coming together. This is a high-level overview of what you see in the main box there in terms of what we're considering to be the core application. That will include an analytics suite that can calculate the metrics and store model history and updates around generating the alerts relevant to the performance, that will interface, of course, with a backend database that includes, among other things, an inventory and our institutional registry and the relevant data and metadata associated with that. What you see off to the left outside of the application is that we are creating an external, essentially a data mart out of our data warehouse that will house, informed by multiple systems, the fundamental data elements that are inputs to this. I'll come back to the top left in a moment. To the right, you can see that the performance dashboard itself, which I'll show you some mock-ups of in a moment, and the accordion snapshots are how one would interface with this. And the ability to generate reports, as well as enable communication and messaging there down below with bidirectional feedback on the use of the model itself. And off to the top left, then you can see, again, some of those functions and capabilities that are informing this. Here is an example of an early mock-up of what it is we are then building. You can see the top two examples here are, in fact, our two VTE algorithms for demonstration purposes that would include, for instance, at a glance. And here you could think of this as if like I happen to co-chair our AI governance committee. So if you were sitting in that committee on a monthly basis, we can look at a dashboard that will tell us what is active across the organization, some general information about state activity, the class. Is it a clinical algorithm? Is it otherwise related to operations, what have you? Where is it deployed? To the extent that it has a CDS element, what is the acceptance rate? And then selected metrics with some indicators of red, yellow, green kind of status. If we start to see one that is aberrant, then we would want to initially be able to just accordion out and get a little bit more detailed information about that, including some issues around temporality and what's been changing over time, and be able to interface with the different metrics, as well as know who to contact. And what I'm not showing you here is an even deeper dive where we could have a much more complete information about the algorithm that then we could use to take further action. We also are envisioning, as we're doing this work and continuing to keep focus on the idea that while we are building this initially for the purposes of evaluating its characteristics and its role and its effectiveness for local algorithmovigilance, with an understanding of its use and relationship to governance and oversight, the importance for technology and human-driven monitoring, our ability to respond to issues, and then capture and report events, that we also envision a world where, whether everyone's using the same system or some standard-based capability that functions the same way, that there could be exchange of information, for instance, across a network like this or otherwise, with some federated capability for algorithmovigilance, so that others could be alerted if they were running the same kind of algorithm about potential consequences, and ultimately, if there's a need for further reporting, that could be enabled as well. Finally, I'll just conclude by saying briefly that, again, we have a third aim in terms of really developing our AI proactive risk assessment toolkit. We are in phase 1 of that, so we're not going to belabor that one in the interest of time today. We really wanted to focus this update on the first two aims, but I didn't want to lose sight of the fact that this is an important part of our project, and we're happy to come back in the future to provide more updates on the progress of this. So finally, in terms of impact and future directions, again, our evaluation of AI-CDS in diverse settings across both adult and pediatric populations, as well as rural and urban settings, is an important aspect of this. We expect short-term impact in terms of adding to our evidence base, as all of these projects are meant to do around the pragmatic use and deployment of these solutions, specifically here around HA-VTE. We see natural expansions of this that will inform future work and future studies as well of the algorithmovigilance capabilities and their impact on what we do around AI-CDS. And again, I think it's going to be very useful to have this proactive risk assessment framework that will emerge from this work as well. So with that, I will stop. I know we ran through a lot of information, but I'm glad we still have some time, and I will take this off the screen and turn it back over to Vinny and Karandeep.
Great. Thank you so much to the Vanderbilt team, Peter, for that inspiring, complex presentation. There's a lot to dig into there. So I think with that, I'll turn it over to Karandeep to provide us some comments.
Thanks, Vinny, and thanks, Peter. Congrats to you, Peter, Colin, I think Lori, Megan from team from Vanderbilt on just the tremendous, I think, vision to do something really broad from soup to nuts, and to also lay out the science behind, you know, the thoughtfulness with which you've approached both the evaluation of effectiveness from a AI-CDS tool, both originally as it was built in Clarity and now kind of trying to do this in a real-time sense with a prospective evaluation. And then also on actually taking the concept of algorithmovigilance and turning it into a product that actually can be used in a health system context for governance and to support all kinds of activities. So I'll share some thoughts on, you know, high-level thoughts on AIM-1 and really what lessons we should maybe take away from it and some of the challenges that I'm sure you've thought about and that you'll be aware of in trying to do AIM-1. And then I'll drop to AIM-2 and talk about some of the open scientific questions on AIM-2, because AIM-2 I think is super critical. And yet I think, you know, as you do it, you're going to have to answer some open scientific questions. So in AIM-1, I think, you know, I hear this comment sometimes that AI implementation science like isn't really its own field. There's kind of a lot of work happening already in implementation science. There's already a lot of folks thinking about AI. So kind of is AI implementation science its own field? And I think your presentation highlights exactly why I think that it is. Because there's a whole continuum of activities you have to do, some of which are not unique to AI implementation science, but I think some of which are. So as an example, I think development and evaluation of algorithms, design of AI workflows, usability testing of those workflows, clinical efficacy and effectiveness of the workflows to make sure that the original model that you developed and evaluated actually does the thing that you're trying to do. Ongoing vigilance. I think you touched on algorithmovigilance, but if you look at the, you know, the mock-ups that you guys made, you also touch on usability vigilance, like acceptance testing and, you know, getting acceptance measures. And I would say potentially effectiveness vigilance. If you are trying to use an algorithm to do something and that thing stops getting better or starts getting worse, then you have to really take that as a moment to say, we probably do need to do a little bit of a root cause analysis of what's going on here. And I think the reason I think this is a science is because there are recognized equator network reporting guidelines that touch on several of those aspects. Mm-hmm. There's one on development evaluation, at least Tripod AI. There's another Probast AI. There's at least one that touches on usability testing and first in human testing, which is Decide AI. And then there's at least one that touches on clinical efficacy, which is Concert AI. And so I think the fact that the scientific community is independently thinking about ways to report the science should let us think definitely this is its own field, this is its own science, and there's a lot of cross-disciplinary expertise to be able to do this from soup to nuts. And then I would say, you know, the other thing you touched on, which also is, you know, again, some of the nuances you have to understand to do AI implementation is like Colin, you highlighted the importance of timestamps. And timestamps are important and they can be different in the research context, different in the operational context, and different in the real-time operational context. And in many places we have separate operational databases as we do research databases. And so, you know, and timestamps can update when certain fields like vital signs get verified, confirmed. And so even data availability, all those things, challenge us. I almost want to go back and look at that net benefit, graph that you were showing, but there's like a clear lesson there because you showed the same algorithm in validation, the same algorithm in clarity, and there's a massive difference in the net benefit that you achieve. So the other thing I would just applaud you on is very few, if any, people really even think about net benefit, not the measure, but the concept. So I think many people look at the kind of broad performance they get and they say, that looks like a good place to set a threshold. Let's go with it. And I think net benefit asks the question, is it possible that deploying a model is actually worse than doing nothing? And the answer is yes, it is possible. And it really depends on what you're trying to use the algorithm for. And so I think I almost view it like as that initial bridge from development evaluation into design of a workflow depends on what is the harms of being wrong if your model predicts a false positive. What are the harms of being wrong if your model predicts a false negative? Having some relative sense of which harm is worse and using that onto your achieved performance to look at, is this good enough to actually do something with? Oftentimes we never stop to ask that question and we actually just deploy. And the answer isn't what's the right threshold. The answer is it good enough? And maybe there's a threshold that lets you achieve that. And maybe there's not a threshold that lets you achieve that. So I think that's something that is, again, part of our toolkit that often gets thought of like as a metric, but it's more of a thought exercise when you're trying to implement something. The other thing I think that you'll have to think about is resource constraints. And so if you do flag a certain number of people, but you're having to screen through, a number of charts and you actually don't have the availability to screen through all of them, does that actually in the real world affect how good your model is? You can have kind of a positive net benefit, but when you apply real world research constraints to it, you actually end up having a model that actually no longer works. I love the outcomes you selected. I think, VTE incidence, length of stay, readmissions, bleeding. I would say one of the challenges from an operational lens, though, that I would challenge you is, does the business leader in charge of VTE at Vanderbilt have skin in the game? Not are they part of the team? Like they may be part of the team. Do they have skin in the game? Is this success of this project tied to their incentives in some broad, direct or indirect way? And I honestly would think, if they were talking to the CEO of Vanderbilt, the CEO of Vanderbilt, VUMC would ask, how does Vanderbilt fare on VTE compared to other places? If we're in the 99th percentile and you're great, then I actually think you may be doing an awesome job in improving care further, and it may be not viewed as a high operational priority because on paper, Vizient, for example, says that you're doing well. So that's actually the other piece is, anytime someone picks an issue, I say, that's a great issue, but go find out how we're doing on that. Because whether this is sustainable will really in part depend on what is our current performance. If you can show we're bottom quartile, people, and there's a clear other incentives and measures linked to it, now it becomes not just a research priority and not just a translational priority from a standpoint of successfully funded research, it gets viewed as an operational priority. And I know with your various roles, like you're deeply ingrained in that world, and so you recognize that. Cost, I think, of sustainability and sustainability more broadly. So cost is an issue of, let's say this works. Who's going to now pay for the infrastructure, the vendor costs, the overhead cost of just doing these evaluations, and then actually the opportunity cost? Some of that will be covered by AIM-High funding. Much of that may not be, because there's just unmeasured costs that go into this kind of work when you take it from the research world into operations. And I think sustainability is the most difficult one that I've dealt with, not financial, but actually what's the support model? And what if someone calls the help desk about something? Whose job is it to fix it? And so the question always becomes, at the stage where something works, do you now try to transition it into the marketplace with a spinoff, a licensing deal or something? Or do you take on that responsibility? Like if Peter, if you ran for president today, let's say, and became president of the US, right? Like who behind you is going to maintain this tool? So I think the question always becomes not that we think any individual person is going to leave, but what is the unit that ultimately is the home unit of an algorithm, and as opposed to thinking of it from a standpoint of which researcher owns it, because units are the sustainable maybe piece within the infrastructure of a health system. So going on to AIM-2, couple thoughts. I think model monitoring, I think you helped put it on the map with your algorithmovigilance paper, and it's often poorly done in the real world. It's often rarely understood. And there are like real questions about what to monitor. And you touched on some of them in that mock-up. I think some of them are operational measures. Is the model even up and running? I can't count the number of times where something was supposed to run as a cron job in AWS at like 6 a.m. And for some reason, some other server went down and someone took something down. And so come like 7 a.m., the score hasn't generated yet. And so there's like a Teams chat going around of like, do you know why that happened? Why did our monitoring system fail? You know, so I think it's not common, but it does happen. I don't think we always get to like 99.9% reliability for the tools we actually use and update frequently. So I think that's one. Usability, I think you touched on. Sample size becomes important. You deploy something in an inpatient setting, there's not that many inpatients. So to be able to make definitive statements around the model's better or worse means you need enough of a sample size of people you're monitoring and enough sample size of people who actually are flagged by the model. And that can take some time. And I think there's this concept of leading and lagging indicators. And I think AUC is often a lagging indicator. You need a pretty reasonable sample size before you can trust your AUC. So just because your AUC is consistent or inconsistent doesn't necessarily mean anything kind of early in the monitoring process. So I'll kind of close with maybe some thoughts on the open scientific questions when it comes to monitoring. Because I think being on the AI governance side of things, we wrote a paper on data set shift and what the clinicians should know about it. And we had a table where we talk about, essentially it's like, go do a root cause analysis and bring it up to AI governance. We didn't really have many answers, but we had at least a process and a way to flag that this is not a technical problem. It's usually a socio-technical problem. So you have to bring it to some kind of governance where you can chat about not just the technical piece of why it's getting worse, but the social piece of what changed. Was this an EHR update that led to some field changing what it meant? Or we changed our clinical practice and we would expect this change to happen. The challenge I would throw out to you and to, I think, the folks on this call is, here's my thesis. If the intervention is effective, you should expect the model performance to change when you deploy it. Sure. Okay. And there's two examples I'll share, which I want which I love folks to think about. One example is the model predicts a bad outcome, like a VTE, and your intervention prevents the bad outcome because you have a really effective intervention. In principle, if you're monitoring the model performance, the performance should start looking worse because in patients where the model thinks they should be having a VTE, you have intervened, and so they're actually not having it. Now, that's where the randomized design helps, and you can actually unpack that. But you could imagine when you're doing monitoring, we're often not stopping to randomize. Now it's like just everyone's getting it. There's no control group. So it can be really difficult once something is deployed at scale to actually figure out if an AUC gets worse. Is that because you actually did a good job at what you were supposed to do? So I just posit that, expect an AUC change when you start using a model, if the model works. And I almost wonder if you don't see an AUC change, maybe it's because no one's using your model or your actual intervention isn't doing anything. The flip side of that is maybe you have a model that predicts an action and your intervention consists of taking that action, like prescribing a drug. In that case, you should expect that the performance should improve because now every time your model says, hey, you should prescribe warfarin for this patient, you notice that magically people get an alert, they believe it, and they start doing it. And if, in fact, that was the whole point of your intervention, you would expect the AUC to be 1 if people are truly 100% trusting your algorithm, which they shouldn't, but if they were, you should expect the AUC to budge in that direction. So I think the open question really is when we see changes in performance or changes even in behavior, what do we do about it? And sometimes the answer actually is don't just do something, stand there, right? It's do nothing. And so I just think there's an open science here that maybe you and I know Sharon Davis and some other folks on your team are working to develop around when should you actually do nothing because you expected the performance to change because of the causal pathway between the action you were taking, what the model was predicting, and the outcome that you're trying to improve. So I'll kind of close there. I think that was broad thoughts on AIM-1, AIM-2. Would love to hear your reaction and thoughts from others who are in attendance. Thank you.
Thank you, Karandeep. I think I'll just make a comment here that I think this is such a fantastic seminar because rarely do we get, a set of folks who are so deeply ingrained both with the technical aspects as well as the governance or health system-wide implications. And I would just say in the social technical platform, which is essential here, there's also the social part, which I think speaks to what are our values and principles and how do we deploy these tools in order to meet those. And I think, yes, we can improve on the technical aspects of, monitoring systems, the entire pipeline, reducing the translation aspects from research to, real time or clarity, whatever it is. We can even improve the insights and actionability for governance committees or end users. But ultimately, there's also a values question here. And I think that it's just amazing to see leaders like you guys, I think struggling with how we balance all of those things and how we build systems that are robust and aligned with, our values as people and as leaders. So I want to see if there are questions from the group. So if folks want to raise their hand, I will call on you. But Peter, Karandeep made a bunch of comments. I think I'm sure that you're thinking about a lot of them. But if you want to give some, kind of quick response or your thoughts as well.
Yeah, really fantastic discussion, Karandeep. Thank you. And I just have to say, I think you hit so many of the points that I was hoping would come across and even more. So thank you for that very thoughtful reaction. Just a few quick comments, because I would definitely like to hear from others, and my colleagues may have more to say. I think, you just going back to some of the comments you made about the net benefit piece, I know definitely that's a lot of the discussion we've been having internally. And your fundamental point about let's just make sure that first of all we're actually doing no harm and potentially doing something good here rather than making that assumption. We have had that discussion. There is currently sort of a non-AI based sort of approach to a fair amount of the decision making that's happening, and comparing it to that is even important, right? And across different settings. So there's a lot of that has informed the work that Colin was presenting, and definitely I know he could say more about that. Your points about sustainability are really critical. That's a big part about why it is we wanted to include our regional campuses and our rural-based settings, which are on the same platform, but necessarily less well-resourced than our main campus in many ways. And so we really want to use that as an opportunity to think about this not only at the sustainability level in terms of the main campus, where we necessarily have a lot more in terms of resources and focus, but also how would we operationalize this and keep it going and sustain it in addition to all the other sort of socio-technical considerations. And maybe I'll just conclude with a quick response. I think your articulation of the opportunities and research agenda around algorithmovigilance was a great start, and there's so much to cover there. I think being able to actually see the patterns that are evolving and actually start to articulate and understand how those patterns start to reflect what's the underlying issue. So for instance, your point about, a data interface breaks and all of a sudden the alert just stops. Well, you're not necessarily going to get feedback about that, right? And especially in an environment where you've got a whole bunch of CDS, I mean, oftentimes people are just going to be happier, not necessarily sort of raise that as a concern. And yet, that's potentially a problem, especially if it's something that was actually really meaningful. And for that matter, you might end up, significantly having harm and not seeing that until it really starts to pile up and you have some catastrophe. At best, you see it at a quarter level or an annual level, and now many people have been harmed. And I think finally, the idea of kind of that analogy to the Hawthorne effect, right? So that, in this case, you're not just observing something and that observation changes things, but you're actually intervening, and of course that's going to change things. And therefore, how do we account for that? How do we make sure that we actually sort of recognize that? And then, I think we're going to get much better over time of understanding what are the types and classes, and we've been doing some of this work too, what are the classes of algorithms that actually will likely have that sort of behavior and what isn't. And I really appreciate you bringing up our colleague Sharon Davis, who unfortunately couldn't join us today because of a conflict, but she's been really instrumental to a lot of this work as well. So let me just ask my colleagues real quick if they want to add anything else to that, and then I'd love to take questions.
Yep. I'll just chime in. I think a lot of the points resonated really well with us, and aligning, that business metric that matters so much to the person, thinking about that at the health system level and making sure that's as close as possible to what we're doing really hits close to home. And then I just dropped in the chat, there was some of our thoughts on this. I think you spoke to it so eloquently. The paper, my grad student, Matt Leonard, he's now graduated, wrote a few years ago, and the title is "Prognostic Models Will Be the Victims of Their Own Success." And it was very much around the idea, if we do a good job, we actually will make our, so if we're not careful about it, we can make our work look harder. So I just love that you highlighted that.
Yeah, no, I love that paper. I've read that, and thanks for sharing that in chat.
Yeah.
One other random comment I'll make, because I have to make a random comment, is that's the first time I've seen TIBCO mentioned in a slide deck. Those of you who don't know, TIBCO is the only company that makes an alternative R runtime as compared to the open source like GNU version of R. So if you're like an R user, like you'll randomly come across TIBCO because you're Googling like, how else can I run R other than the main R runtime? What are the other implementations? And TIBCO is the only commercial provider of a R runtime. So really random. I was like, that's the first time I've seen that here. I'll share a link in chat.
Awesome.
I also will make a comment that Karen D, please don't ever suggest that I'm going to run for president again. That was very off-putting. Yeah.
Yes, I thought that was a comment that needed to be followed up on. So will you be traveling to Florida, just to make your presence felt there? No, I'm going to actually pivot us as well in our last 9 minutes. There's so much material and discussion here and so many, as Karan Deep suggests, unsolved issues, science that needs to be executed on. But let's look to the future. So, Peter, your work is successful, whatever. Let's say we leverage Databricks for a seamless, pipeline or other tools. We have that interplay between the interface and our decision makers, as well as our end users. It's all working great. We have 50 models, 100 models at scale, right? Mm-hmm. And then jumping to Karan Deep's kind of point about nothing is going to be able to run at that scale based on one person. What does workforce development look like? Right? Like who, how, are we building the people and the teams to be able to handle that frontier? And just in both of your positions, leading in your health system, how are you thinking about the capabilities and the bench, that will need to be developed for that day?
Yeah, it's a really, really great question. And the honest answer is we don't know. And we're sort of trying to keep an eye on that and figure it out. But we certainly agree that basically, I think the short version of this, which is perhaps not a great answer, but I think is where we stand, is that we, as we are building this out and trying to think about, for instance, when we start to not only maintain these systems and have them function, but actually then observe results that or findings that actually cause us to need to take some action. There are some people in current roles that potentially can be repositioned or are already kind of an expansion of their current scope may be adequate to actually allow for this being within their role, saying, let's say, take an action to sort of correct what have you. There's others where we're clearly seeing gaps where if we said, well, who would be the right person in our workforce or role in our workforce to actually address this concern or this need, and we aren't finding one. And I think as we expand the development and use of this, it's going to increasingly illuminate that. The work that we're doing now involves also what a lot of us I know struggle with at the sort of academic and operational divide, which is that a fair amount of the expertise we really need to bring increasingly over to the operational side lives on the academic side of the house. And so one of the things we are actively navigating is being able to make the case for that and recognize, well, how is it that we're going to actually pivot some of the people who have, you know, the data science expertise and other kinds of capabilities, and make sure that they actually have some operational support, but also that they understand what their role is going to be, which is fundamentally different if they're going to take on these kinds of duties. Or in fact, do we need to be, you know, creating new job roles and hiring new individuals and bringing them in? So I don't know that that's a satisfactory answer, except to say I would confirm your thought that we currently don't have it all figured out or the right people in all of the right roles. And I think we need to evolve that.
Yeah,
Karandeep, any thoughts there? Yeah.
yeah, I would second a lot of that. What I would say is one of the things I'm trying to do is first educate our leaders on what are appropriate uses of predictive versus generative AI. Kind of before I got to UC San Diego, there was a generative AI idea wave that was held where people had the opportunity to submit ideas of things that would be relevant in their clinical workflows. And so 129 ideas came in from clinicians. And I would say, you know, like 5% of those were generative AI. And so I think it is important for our leadership to understand what is the right tool for the right job and what are the limitations of each tool. And like a basic thing as simple as saying, if we're predicting a current practice, we're not going to change the practice by acting on the prediction of the model. That's like a basic sort of kind of, people just know that in the you know, kind of our sense of like who have domain knowledge. But sometimes leadership will just say, well, can't we just predict the billing code and then we'll bill better? It's like, no, not based on our current practice. If we had a desired practice that we could predict for, that's the sort of thing that we would want to anchor to. And that's why we need vendor partners, because we often can't do that kind of work single center with just our data. The other thing though is our intake process has been refined a little bit, which actually serves as an education opportunity. So we launched a process called AI Think Shop. You have an idea, you have a potential vendor, or you have a potential thing that you'd like to do, bring it to AI Think Shop. And that's where we actually think about, like, what's the problem you're trying to solve? What's the outcome you're trying to achieve? What is the tool you have in mind? And what are some alternatives? And I think that honestly helps people really appreciate the limitations in some cases, and in some cases helps pivot them into where they actually can be effective, and also can kick off our contracting and procurement process. So it's our project it's a co-led by project management. So if something like resonates at ThinkShop, we can then resource it with project management to be able to actually execute on it. So I think it's the kind of full health system, and that's a shared activity between health innovation, our information services, and the project management office. What do we do for frontline? We do have an AI, infrastructure, and a lot of places do to whether it's Nebula or whatever, whether it's a custom thing. But I view that as that's like largely useful for clinical researchers. It's not like a useful thing for every kind of clinician at their bedside, short of the work that we do as a byproduct of that. I do think though that there are lots of things you needed to write custom code for that you can approximate with large language models today. So I think HIPAA compliant LLMs for everyone is a key kind of priority that we're trying to put in place. We have a campus fine-tuned version of Llama 3 that is fine-tuned on all this like campus documents, and that's great for campus, but we're working on and we have, for research side, we have like Azure and GPT, but we're looking for a front-end facing kind of user experience that lets us do basic kind of things. And if we can do, I think, some of those basic things, then the education we really should be out there doing is prompt engineering 101. So a lot of my talks to divisions and departments, maybe not my first talk, but my second talk is really prompt engineering 101, to show them how you can take some task that you would have had to do in a really bespoke way, or with a really intensive kind of chart review type process, and potentially do some of that task with assistance from large language models, prompt engineering, and retrieval augmented generation. So I know this wasn't about generative AI, it was more about predictive AI, but I actually think that's where a lot of the user-friendly tools are currently existing today that are, I still think, in healthcare, highly, highly, highly underutilized for back office and basic tasks that we do every day.
Yeah, very well said.
That's great. So I think, Karandeep, what you're saying is kind of like some of the literacy gap, AI literacy gap, really can be enhanced through LLMs, and that we're not necessarily having to train people through the process of understanding code and develop, like, which has kind of been a little bit more of the traditional pathway, and that massively reduces the kind of on-ramp time for a lot of relatively not as complex tasks, but knowing LLMs can handle a lot.
And there's still a literacy gap in the space of LLMs. Like, as an example, if you use GPT-4o today and you ask a question and you get an answer, but if you ask it the same question and you say, look it up at the end of your prompt, that forces it to do a web search and then use the web search results with retrieval augmented generation to answer your question. And so that's like a simple thing, but I tell people, if you're using a tool that has access to web search, force the web search to happen by saying, look it up. A lot of these are like, they're called tool calling or there's function calling, but there's these like phrases or keywords or incantations you have to say to get the thing to do what you want. And it's very different than the, traditional programming sense of the way we used to teach people, but it's still, I think, just as important so that people understand what are the things at their table. And it's not just a conversation that you're having like you would with a friend.
Fantastic. So maybe I'll end us on that note. It's the alchemy and wizardry of health AI is the new frontier. With that, I mean, this was just really a fantastic presentation, an overview of many, many salient issues to health system implementation. So want to thank the team from Vanderbilt, Karandeep, for making the time, and thank you all for joining us.
Thanks, everyone. Really appreciate it.
Thank you.
For the comments there, tracking them.
Thanks, everybody.
Thank you, everybody, for
Okay.
joining us.